Good morning, everybody. We're just going to go ahead and take a couple minutes to allow some of our participants to filter in here. So just give us less than 2 minutes and we're going to go ahead and rock and roll then. Okay. Welcome back, everybody, to this ongoing webinar series, Building Smart Energy Efficient Essentials for Modern Homes, sponsored by DTE and Consumers Energy. We appreciate the partnership here at the Midwest Energy Efficiency Alliance in working with DTE and consumers to be able to deliver this ongoing series. And really kind of the name of the game for this series is trying to level up all of your professional knowledge of all the various elements of building performance so that when you're working with your customers, you can help them deliver the best possible home so that we are incrementally improving our housing stock here in the state of Michigan to make people have more comfortable, durable homes with better air quality and lower energy bills. So today we have sort of a unique presentation. We're going to be focused on all things solar. So it's a little bit different than I think probably most of us deal with. When you think about energy efficiency, you don't necessarily think about solar first because usually we're thinking about insulation and air tightness and mechanical systems. But solar is a big part of kind of rounding out and finishing the circle of what it means to have a high performance home potentially. And it doesn't mean just one thing. We're going to be talking about all things solar here in today's presentation. So, getting into just what are the various types of solar energy? How do we know if a home is suitable for solar? Solar readiness versus actually having solar on a property. And then what kind of incentives and programs are available? And then finally, how does this fit into ERS ratings, energy code, and above code programs? That's kind of how all the presentations that we've been delivering sort of end up is how do we actually apply this? Again, if this is your first time taking one of these presentations, I'm Chris McTaggart. I am the co-principal and president of Building Efficiency Resources. We are a national ResNet quality assurance and training provider. We work with about 500 ResNet professionals all across the United States, and we have several raters located specifically here in the state of Michigan. I myself am a native to Michigan, live in the city of Detroit, but I've been all throughout the state, west part of the state over by Grand Rapids and Holland and the sort of the Gold Coast shores up to Traverse City and Petoskey, Charlevoix, that great part of the state, the eastern part of the lower peninsula, Alpena and Tawas, and even in the Thumb region, Port Huron, all the way up to the Upper Peninsula. Spent some time up in both the eastern part, Tequamanon Falls and Pictured Rocks area, Drummond Island, and also over in the far western part, over where Marquette is, and the Keweenaw Peninsula, Houghton, Hancock, all the rest of that good stuff. So I've been around the state of Michigan, and so I have a pretty good idea of what's going on from a building perspective, and so that's why the Midwest Energy Efficiency Alliance, in conjunction with DTE and Consumers, brought me in to be a presenter for this series. So I'm looking forward to continuing the conversation today on solar energy. So again, something a little bit different than the more sort of sticks and bricks elements of construction that we've been talking about to date. So first and foremost, when we're talking about what is solar energy, it's only the most important form of energy in our, in our solar system, and for the Earth. If it were not for the sun, we would not exist. Humanity would not exist. Every other species, just about on planet Earth, plant or animal, would not exist if it were not for the sun. So pretty important thing when we're talking about solar energy. And I think when we say solar energy, most people go straight to sort of the third application here, which is solar panels, solar photovoltaic panels. But that's not the only form of solar. Arguably, when we're talking about building performance, and particularly in a climate like ours in Michigan, passive solar design is actually arguably an even more critical element. You can build every house with solar energy in mind by building in passive solar design. And you don't necessarily need to have a traditional mass home, something with a lot of concrete and tile and things like that in order to have a passive solar design. Just good decision making in the design process can help to promote passive solar design. Things like optimal orientation and optimal solar heat gain coefficient and optimal overhangs can go a long way in order to make homes more resilient from a passive solar perspective. There's also solar hot water systems, aka solar thermal. Again, these are not solar panels, but these are a different technology that basically help to use the sun's rays in order to specifically heat up a glycol heat exchange product from the roof that goes through the collectors and then puts it into a hot water tank. And so that allows us to have efficient water heating or even space heating via solar thermal systems. So if you think about this, you think about trying to go more green and having like a high efficiency all electric home. Not everybody necessarily is sold on a heat pump water heater. Why? Well, heat pump water heaters, um, they're, sometimes they may not necessarily fit in our homes. They do require a certain amount of uh, free heat and open space in order to operate functionally. So if you want a high efficiency electric based water heater, and a heat pump water heater is not going to work for you for whatever reason, you may consider solar thermal. Or even if you're, thinking about doing hydronic heating, so basically, water-based heating, through what we would typically think about as a boiler, you can actually accomplish the same thing with a solar thermal system. Again, to have a high efficiency, all electric form of space heating using the sun. So we're going to talk about all three parts of the solar equation here, because all of them have room within, basically the sphere of building performance. Now, one thing I'll make sure to point out here, and we'll talk a little bit more about it when we get to the application to HERS ratings, as well as the application to incentives. All three, passive solar design, solar thermal, and solar voltaic, are a part of the HERS rating calculation, and they can be used for demonstrating compliance with above code programs. Some programs don't necessarily allow you to take credit for solar PV in order to meet the ERI calculation. Like Energy Star, basically, you have to meet the ERI reference design index without PV. Same thing for zero energy ready homes. And again, we'll talk about this later on. But you can use solar thermal systems because solar thermal is not considered to be on-site power production. We're not producing kilowatt hours, we're producing BTUs, and there's a difference there. It's more of a form of a mechanical system versus some form of electricity or on-site power production. Same thing for passive solar. With a passive solar design, we're intentionally designing the home in order to capture useful solar radiation that can be used to passively heat the home. Basically, and what I mean by that is with no mechanical system, basically just having the sun shining through our windows and then potentially absorbing into our building materials can help to provide free heat for the home. Now, you're not going to heat your entire home with passive solar. It's been done before. It's challenging to get true passive solar where you don't have any type of mechanical system providing supplemental heat. That's very difficult to accomplish in reality. But if you have a passive home that's extremely well insulated and airtight, then capturing the solar rays through our fenestration, absorbing into the materials of our home, and then giving off that heat once the sun goes down, that absolutely can be a strategy, and it could reduce potentially the majority of your mechanical heating that may be necessary for your home. But you got to make sure you're pairing it with appropriately sized overhangs so that we're not overheating our home. So those types of strategies can also be a part of the HERS rating process. They can be part of the Energy Star and Zero Energy Ready Homes process as well. And I'll say passive solar and solar thermal can be strategies that are used within the energy performance calculations used for the new homes program through DTE and Consumers Energy. Solar photovoltaic systems, though, are not considered. So when we start to talk about solar photovoltaic, just understand it may be an appropriate practice for many homes and many homeowners. Certain builders may choose to spec having solar PV systems on their homes that they're selling, but you're not going to get credit within the DTE and Consumers New Homes program if you choose to put solar PV on your house for the sake of incentives. All right, having cleared all that, let's just talk about, so what are the benefits of going solar? Well, again, cost savings. Imagine we have a home where we're capturing the solar radiation from the sun, and that free heat is heating our home in a way that actually is beneficial for us. Well, that's independence. All of a sudden, we don't need to have oversized heating systems in order to keep ourselves comfortable in our home. And that really reduces costs. Certain systems may increase your property values because they're a element, whether it's probably not passive solar. I don't know that most appraisers are going to see the value in that per se, but they certainly would see the value in a solar thermal system because it's an advanced mechanical system, or a solar electric PV system could also basically increase property values as well. There's community and grid benefits when used appropriately. Imagine that we had a solar thermal home, so we're heating our water with the sun. Well, that's one element that doesn't have to be basically provided by the utility. And that's really great because it tends to be that people are using a lot of hot water first thing in the morning, and then when they get home from work. Well, that's kind of like when the grid is under the most stress, particularly when people are getting home from work. And so if we can offset some of that energy need by appropriate design with passive solar or solar thermal, or even having solar PV, it's a good idea. With solar PV and things like really all these technologies, you can be better prepared for an emergency. What do I mean by that? Well, imagine that there was a major storm, like what happened in the northern lower peninsula this winter, where there was that major ice storm around Harbor Springs, Petoskey area. Well, the grid was out for like practically a month in that area. Now that was more in a rural electric cooperative area, so a little bit different than DTE and consumer service territory, but still, the issue is that if you have a major event that happens like that, if you're completely grid tied and you have a home that you're not bringing in much passive solar, and you're not producing any electricity, you're probably going to have to rely on a generator. Then you're going to have to rely on a generator in order to to basically heat your home, or some form of auxiliary type of heating system. uh, it would be kind of nice in a situation like that to have, a battery with solar panels so that you can keep your home going even under an emergency condition, or that your home was built with passive solar in mind, so that when you're heating your home through the sun, it actually helps to keep the temperatures stable. It's called resilience. And then finally, of course, there's environmental benefits. All of this stuff that we're talking about, all the building performance and energy efficiency elements that we've talked about, they all have an environmental benefit. Barriers, there can be some upfront costs, obviously, things like, um, good design. There's a cost to good design for passive solar. The materials for passive solar, I wouldn't say, are particularly more expensive. Windows with better solar heat gain coefficient, that are more appropriate, that's not necessarily going to cost you a lot more. But kind of thinking through the design process and making sure that your architect builds in appropriate sized overhangs, that is an important detail that you have to think about. It costs money in design. A standard set of builder grade plans may not factor these things in. And what happens if we take that standard set of plans and then we're going to build it for every cardinal orientation? You're going to have a home that's oriented to the south, oriented to the east, to the west, to the north. Are we able to modify the design even for those stock plans in order to do things like solar, passive solar type of design? That would be the best. So that way the home looks good no matter the orientation, and we're able to take advantage of passive solar. um, let alone things like, solar PV, which clearly is a cost. Adding solar to a house, solar panels to a house is going to cost more money. There's no other way around it. Installer availability and quality, again, it kind of just depends on what system you're talking about. Solar thermal, for example, you have to find a specialty contractor to do solar thermal. A builder that knows how to implement passive solar may, not every builder necessarily is educated on this yet, let alone solar panels themselves. Permitting delays or restrictions, again, maybe solar thermal or solar panels, maybe you're in a community where they don't allow you to put them on like the front of your house, or maybe not at all. You may have to look at an HOA covenant to see whether or not you're even allowed to do some of this stuff. I can't imagine that there's going to be much preventing you from doing passive solar, but you may have to think about that. When it comes to solar panels, solar electric panels, PV panels, integrating them in the grid is how we do it is very important, because there's such thing as potentially there being too much solar in the mix, where all of a sudden you create a perverse incentive to potentially, as a utility, downsize other more sort of continuous forms of power production, because you have solar panels providing a lot of power during the day, but when the sun goes down, all of a sudden now you're not providing as much. So I'll say it's very important, if you try to go and put solar PV on your house, you have to get it approved by the utilities in Michigan. You can't just go and throw it up. Has to be, basically permitted not only locally through your jurisdiction, but the utilities themselves have to sign off on your plan because they want to make sure you're not overloading the house. In all of these things, builders, most builders don't ever think about passive solar design. They could be doing it on every single one of their homes. They're not necessarily informed about it, let alone things like technological solutions like solar thermal or solar electric. So, the different types of solar, again, passive solar, every house could be doing this. And to a certain extent, every house does. Just about every house, whether you're intending to or not, is taking advantage of the solar arrays from the sun for the purpose of space heating. I have a house built in 1927 in Detroit. It wasn't intending to capture heat from the sun, but my windows are in fact capturing heat from the sun in the wintertime in order to provide some free heat. And when you model a home in energy modeling software, there is an accounting for that, the amount of free heat you're getting from the sun. Unfortunately, it works both ways. In the summertime, if you just leave windows exposed to the sun, then all of a sudden you're going to be bringing in a lot of BTUs through those windows that can cause you to need to air condition the home. So passive solar design is not just let's make a house with more windows oriented to the south so we can bring in more free heat in wintertime. That sounds good, but the problem is, number one, you can overheat the home. And number two, you may be bringing in too much heat, especially in the summertime, and therefore overheating the home and causing you to have to really cool the building in excess. So proper passive solar design factors in all these things, bringing in the sun that we want to, blocking it out when it's not convenient. We don't want to just overheat homes. Again, solar thermal is taking the sun's rays and then heating up water, typically in order to be used as a form of either water heating or space conditioning. And then solar PV, those are our solar panels. So I think that's what most people think of when we talk about solar. I'm spending a lot of time talking about passive solar just because I'm so passionate about it. This is something that you should be working with your builders, or if you are a builder, you should be implementing it on every home. And again, you don't necessarily have to have a concrete house in order to build in passive solar. Basically, the idea with passive solar is that you want to start with a good orientation. What is a good orientation? Well, ideally a home where most of your glazing is going to be oriented to the south. That would be ideal, because that way you can capture more of the sun's energy through that glazing that's facing south, because we're in the northern hemisphere and therefore the sun is in the southern horizon. And so that's why the south facing windows give us basically free heat in the northern hemisphere. So orienting the house in that fashion would be a really good idea, but you can't just add, a whole wall full of south-facing glass. You will in fact heat up the house, but you're going to do it too much. You have to have appropriate overhangs to make sure that we're not cooking the house. How you select the glazing that you're using, choosing the right solar heat gain coefficient. So again, something that's going to bring in enough, but not too much. Going back to the presentation that we had on Windows a few weeks ago, there's a lot of decisions when it comes to glazing and fenestration. Solar heat gain coefficient is one of them. And I would say disservice in our industry has been that everybody just thinks that the lower number, the better for solar heat gain coefficient. Why? Well, because a lot of our new construction in this country is happening in the South or in the West, where it's extremely sunny. And so blocking out the sun is more of a design strategy for energy efficiency. But up north here, it's a balance. We would ideally like to bring in perhaps a little bit more solar heat into the home. And so specifying windows with a higher solar heat gain coefficient can actually be a really good thing. Again, no matter what your SHGC is, though, you have to shade them appropriately. So then in the summer, you're not just bringing in more and more and more heat, because then we have to air condition the building in order to address that heat that's coming in. Passive solar design also requires a better insulated and airtight home. Just bringing in free heat into a leaky barn, yeah, it'll help to heat, but it's not really, you're not going to conserve that heat. And so it won't be as effective as a sort of adjunct heating system as it could be. Couple of thoughts came in. Patrick says, I suspect many builders would have an issue of installing the right windows in the right opening. More training on the issue is necessary. I agree with you, Patrick. Yeah, I think that getting the right package for this type of a thing, it takes more education. But it's something I'm passionate about because, again, literally every single home being built in Michigan could be implementing this to some degree. And it basically cost very little in terms of products. It really is more about a more thoughtful design process. And the big benefit is if done right, not only are you going to reduce your heating costs because you're bringing in free solar energy, free BTUs of heat into your home, and that is going to absorb into your building materials and then give off that heat over a longer period of time, therefore reducing our heating bills. But passive solar design is also about blocking out the sun when we don't want it, basically having appropriate shading or overhangs on windows to block out the heat so the buildings stay cool. So it works really for both seasons. When done appropriately, it can be very comfortable. Be very comfortable to have the solar heat come through your windows and warming up the floors and the walls of your space. Why? Well, because one of the main ways that people feel comfortable in homes is through something called mean radiant temperature. So the temperature of the surfaces surrounding us in our home. So when we wash our interior with solar radiation, it can help to warm up the surfaces. And so even on a very cold day, those surfaces feel very comfortable, and therefore we feel more comfortable. Additionally, you can bring in natural light, daylighting, which has a lot of mental health benefits to people. To be able to see outside and to see and feel the daylight coming in can have a lot of benefit. And again, there's almost no environmental impact for this. You don't have to just oversize your glazing in order to integrate passive solar design. It's more about a thoughtful approach. Solar thermal, again, it collects and stores solar energy and typically transfers it to water. You can do it with air-based systems. I would say it's much more rare that we see solar thermal with an air-based system, but not impossible. Passive solar can have active and indirect systems, so basically passive and active systems. The basic components are that you have collectors on the roof, and then some form of storage, usually a tank. So usually you have a passive, indirectly fired electric tank water heater with coils to do the heat exchange in it. And then you basically have pumps that pump that around the house. And again, this could be used exclusively for water heating, like so for our domestic hot water system, or it could even be used for space heating. You could pump that heated water around through fin type radiators, so that, or in a basically in-floor radiant heat, in order to have hydronic heating. Or you could possibly even do a hydro air system where you have a fan coil type of air handler that has a heat exchange coil in it that basically you're heating up that coil with that hot water and pumping it around the house that way. So, these are relatively simple systems, but they take an expert in terms of design in order to really make them appropriate. Active systems are what we're typically going to be shooting for in our climate. Few different ways to go about it. Flat plate systems typically are going to be a little bit simpler, but they're probably more effective for southern climates. When you're getting into northern climates, evacuated tubes are something you may want to consider more so because they perform better in cloudy climates. And obviously, as I'm sure you all know, living here in Michigan, it certainly gets cloudy in the wintertime. This can really be a big advantage to these systems, is that ultimately these are not electric based systems. These evacuated tubes, they basically are just having a water glycol mix moving through them, and they're pumped through them, and basically that's how we're collecting those BTUs of heat, is through these collectors, and then they're going into a tank, and then that tank stored energy can be used in order to basically move around the house. So good for a place where you have a lot of hot water need, or if you're going to use it as a space conditioning system. Solar PV panels, again, this is when people think solar. I'm sure everybody, when they signed up for this presentation today, thought I was just going to talk about solar panels the whole time. And you'll note that it's the third thing that I talked about. Why? Because in reality, for our climate, doing passive solar and potentially solar thermal actually makes a lot more sense than solar panels themselves. And I'm not saying that to be biased against solar panels. I think that solar PV panels are great for the right home, but they're kind of like the sprinkles on top of the icing on top of the cake. They're one of the last things you should be doing in order to have a high performance home. They work by using semiconductors to convert sunlight to electricity. It produces DC power and then uses inverters to convert to AC power, which we're able to use in our homes. And you can also collect them in batteries. If you don't have a battery, then basically you're only able to use it as it comes in. More or less, the rest of it is being shipped off to the grid, and you get some form of a credit back on your bill. So this is kind of how a PV array works. You've got the panel itself on the far left, and you've got wiring that connects via conduit to all of them. It's grounded to the ground. The DC energy that's produced is hooked up to an inverter, and then basically it's converted to alternating current, and there is a utility connection for most systems. Then you can also potentially have a battery system on your premises in order to store some of that energy that you produce. When we think about the panels themselves, there's different forms of panels. Monocrystalline are actually more efficient. You'd think, oh, wow, it seems like poly would be more efficient. No, generally speaking, monocrystalline panels are going to be more efficient than polycrystalline, as well as more efficient than thin film. Thin film is like almost like take a flexible sheet of a solar panel. You've probably seen it maybe on like marine applications. You could technically go ahead and roll it out and hook it up. It's not going to be as efficient, but it may be more practical for certain applications. Most of the time when we're seeing people installing solar panels today on buildings, we're really talking about mono or polycrystalline type of panels. There's some other specialty type of panels that are out there, bifacial. You can generate from the front or the back. Not generally that appropriate for like a residential application, but you never know. A PERC type system, it's basically an improved version of poly and monocrystalline panels. And then we have hybrid solar panels that do PV and thermal to produce both heat and electricity. So these are all options that are out there in the marketplace. For inverters, again, you need an inverter for a PV system because our homes do not run on direct current; they run on alternating current. So we have to convert that direct current to alternating current using an inverter. And you can basically have a standalone string inverter, basically, which is basically an actual box that is the inverter, and it controls all the panels. Or you can have micro inverters on each individual panels, or a hybrid inverter is used basically both as an inverter and as well as a battery control storage device as well. So there's pros and cons to all these types of systems. There's something nice to think about a hybrid where you get both the inverter plus the battery all in one. I would say a challenge is they're expensive, and then also, one thing to be careful about is these inverters can be sensitive. Lightning storms can cause them to basically die prematurely. So I would be careful investing way too much into an inverter. I would at least check out the warranty to make sure it's good. Microinverters have a lot of benefits insofar as you control each individual panel, and you can basically, like, imagine you have any shading on your system, then you can optimize the performance of that system by having microinverters. The challenge is that there's a little bit more to maintain most people just go with straight string inverters, especially if their house is well oriented directly to the south, or at least south, southeast, southwest, with unshaded roof orifice in order to collect. Batteries, there's a lot of different types of batteries out there. The industry has leaned towards lithium ion based batteries here because of the density of storage. Older school, like off-grid applications, use simpler forms of battery storage that are more chemical, simpler chemical forms. Lead acid, nickel cadmium, those types of batteries. There's pros and cons to all these. Obviously, lithium ion's taken a big part of the market. They are more reactive. And so if you're going to put them in your house, you have to have like a safe room that is like basically a completely drywalled enclosed room, so that if one of them were to cause a fire, you'd be able to contain that fire. The other thing with lithium ion batteries is that they potentially wear out a little bit faster, and they're more expensive than some of these other forms of batteries. And they also are more sensitive to temperature. So imagine if you wanted to keep the battery in like an unconditioned garage or something like that, you may actually do better with a different form of battery storage. The benefits of having batteries, though, is that you can, take a bigger piece of your production and use it. So imagine you're collecting, solar energy, electricity during the day. You're maybe able to power your house during the day, but you also take the excess and put it in the battery so that at night, when the sun goes down, you can still run your refrigerator and your television and your cell phone and your computer and your air handler and everything else. It can be taking that off the battery instead of having to basically produce during the day, but then have to buy from the grid at night. So there can be some advantages, and there can be some advantages to basically real time pricing, basically peak demand reduction. So electricity is the most expensive for the utility to produce during peak demand. So that's during waking hours and particularly the late afternoon. Why? Because everybody's getting home from work and everybody wants to use power all at one time. So there's some advantages to sort of offsetting, particularly that peak demand. That's what batteries are really good for. So you can have roof mounted PV systems. Why would a roof mounted system make sense? Well, it really makes sense where you don't otherwise have a lot of land. Think of yourself as just being like an urban or suburban type of home. You may not have a lot of land to allocate to putting solar elsewhere. Ground mounted systems, though, will typically work really well. Obviously, they work for utility grade applications. So when the utility like DTE or Consumers Energy puts in a new solar generation station, it's pretty much always ground mounted, or for the most part. Why? Well, because it's a little bit cheaper to install and then maintain because it's at ground level. We're not having to go climb up onto a roof in order to maintain that system. So if you're a residential property and you have enough land, ground mounted systems might make sense. You can even do what's called tracking with them, basically where the system itself will follow the sun. Even if you have it oriented to the south, the sun rises in the east and then sets in the west. And so if you're able to track and follow the sun, you'll be even more efficient at the application of collecting those electrons for electricity generation. So there's two different types of sort of applications of solar. The first and most prominent is going to be a grid connected system. That's what most people are going to elect for. This means that you can generate electricity when it's convenient, but then you can also buy it when it's convenient. So basically, you're still a customer of the utility. You may generate a certain portion of your home's electricity using solar panels. You may actually give some of it back to the utility. So if you say you're in a really sunny but moderate day, you're not using a lot of electricity for for cooling your house or anything like that, you may be shipping a lot of those electrons back to the utility, and you get a form of a credit associated with that. But then when the sun goes down, you can still buy the energy from the utility as well. So that's called a grid connected system. The other one is an off-grid system. So that would be, say you're going to go buy a piece of property in a remote part of the Upper Peninsula, and so you're up in the Keweenaw Peninsula, far away from a road where you don't have an easy power hookup. You could actually build a house and power it all on site without a utility hookup using solar panels. In that instance, though, you have to have a battery, because basically the battery is your backup. When the sun ain't shining, then you're drawing from that battery. So obviously the con of that system is you have to really rely on those batteries, because you're going to be drawing power from them pretty consistently. And, obviously you may not produce enough at some period of time. Imagine that your property gets dumped with a foot of snow and your panels are covered up. Well, you either got to get up there on the roof right quick and make sure that you're shoveling them off, or basically you're going to draw off your battery really fast. So there's certainly more considerations with a off-grid application. Not most people are not going to choose this. Most people are going to choose grid connected systems, but it's really important for you to understand, if you're going to do a grid connected system, you can't just go and say, well, I'm going to cover my whole house with solar panels. You have to get permission from the utility for what you're going to put on your house, because they don't want to overproduce. There have been issues with consumers being sold a bill of goods by solar installers. Basically, they've been oversold systems that are larger than what they need. And then all of a sudden the consumers aren't happy with that. Having excessive generation at any given time can potentially be challenging for the utility to implement. They have to make sure that they have enough ability to take that power back. So coordination with a grid connected system with the utilities is paramount. Hybrid systems, this would be basically like a grid connected system, but you have a battery backup. This is kind of the best of both worlds. You get to keep most of the power that you generate. You can possibly even ship some back to the utility. You may be able to supply power to the utility when it's the most expensive or the most energy intensive to produce, such as peak time, and then buy it back to fill your battery when it's cheaper. So in the middle of the night, when there's not nearly as much power demand, that's when energy tends to be really cheap. So if you have a consumer that's looking to kind of go all the way, having this hybrid type of system is something they may want to check out. Is every house right for solar? Well, let's check it out. Again, I would argue that most homes could benefit from passive solar. Unless you're in the middle of an urban environment surrounded by buildings that are much taller than you, or if you're in the middle of a forest where you really don't have any, solar, basically, access to come through your windows, just about every home could be good for solar thermal, or passive solar. When it gets into solar PV, you got to think about the economic application. Is the juice worth the squeeze? Is it worth it for this property? So, for example, my house here in Detroit, I've got a lot of mature, very tall trees in my neighborhood and on my parcel. So, frankly speaking, I might want to have solar on my house, but it doesn't make the most economic sense. So I haven't done it yet. Why? Because I have these big giant trees that are shading my roof, and I don't really have a lot of space for ground mount either. So it's a little bit more of a stretch for me to implement solar on my house. In terms of, assessing it, you got to think about what your goals are. Are you just planning on them paying for themselves over a period of time? Do you want to offset a certain percent of your energy? Are you trying to go all the way to net zero? And how much space do you have for them, and what's your budget? Because Honestly, solar has come down in price substantially, but you may have heard, one of the big drivers of solar PV systems being installed has been a federal tax credit, which will be going away. The solar residential tax credit will be going away at the end of 2025. So, how that will affect system pricing, we'll have to see. There's a really good guide from the EPA for specifying solar PV systems and determining whether or not they make sense. The solar photovoltaic specification checklist and guide. So I would recommend checking that out. Basically, the big things you want to talk about is what's my location, what's the orientation that I would be able to reasonably implement. What about my roof tilt? What about any adjacent shading like trees or buildings? And then basically what's the amount of solar radiation that's going to hit my site that's going to, basically generate those electrons. For my house, not only do I have these big giant trees, but my house is oriented east-west. So I don't have very much in the way of south-facing roof area. So it just makes it more challenging for me to really think about implementing. But it sort of depends. Think about things like mounted versus roof mounted. Even if you don't have a good application for your roof, you might be able to put it on the ground if you have a big enough parcel, and that may actually make a lot more sense. And so, again, what's your goal? Thinking about the size, well, say you just want enough to be able to offset some of your energy use, but not all of it. So you desire to put in a 5 kilowatt nominal rated system. And we're going to use 350-watt panels. Well, basically each panel is about 20 square feet. And so you'd need basically 15 of them in order to get to that 5 kW. That's 300 square foot. Do you have enough space on your roof to do it? Now, and it's not just covering the entire roof. By code, we have to have certain clearances for basically fire safety. You have to be away from the rake edge of the roof. You have to be away from sort of the center, valleys of the roof, and from the peak, we have to have a certain clearance from the peak in order to basically ensure that we have the ability for somebody like a professional, like imagine there's a fire in your home. Oftentimes the way that firefighters suppress fire is they'll actually go ahead and cut a hole in your roof and then spray down into your home. Well, if the whole thing is covered with solar panels, it's going to make it very difficult to do that. So that's a big reason why you can't just cover the whole darn thing with solar. So, checking out through an NFPA 1 fire code, any types of setbacks is going to be really critical for you. Orientation, again, due south would be the best. We get much higher power production from south or southwest, southeast than we do if you have certainly like a northern facing array is not going to produce nearly as much power. The inclination, ideally, you would want to set up the pitch so that it matches the latitude. So, we're somewhere in the 40s, here in Michigan. That would be a pretty steep pitch, kind of difficult to get to that with most roof mounted systems. Don't overthink the pitch too much. Most panels are efficient enough to compensate for not having optimal pitch. But keep it in mind that having a decent pitch helps to collect more solar array. Shading, again, this is not my house in this photo, but it might as well be. I have lots of large mature trees that shade my roof. It doesn't make a lot of sense for me to put solar panels on my main home's roof because of this reason. You can do a professional shading analysis using something like a solar pathfinder, or there's even like mobile devices now. Sunseeker is an app that you can use to get a better idea of your solar potential and to factor in any type of shading that may be occurring. A really good way to go about, sort of the initial design is to go to the NREL's PV Watts system, and to run an analysis, you can basically put in your geographic location and mock up like a sort of a dummy system to see generally how much they think you're going to produce. You have to, use some assumptions for things like losses. So that would be losses from wiring losses, from soiling, from snow cover, from shading, etc. So it does really pay to work with a professional if you're trying to dial it in. But if you're just trying to get a rough estimate, using PV Watts can be an excellent way to go. Other considerations, loads. You have to have enough ability to be able to hold the solar panels on your roof. If we're going to set up the home, for people to install them, we might want to consider to have a permanent roof anchor for people to hook up to, so that it's safer to do maintenance and installation. Other things, again, how much solar radiation is available down south or in the sort of the west Sun Belt. Solar makes a whole heck of a lot of sense. Here in cloudy old Michigan, solar PV, it's not as straightforward of an awesome thing to do. We can also get our panels covered with snow and ice, and that reduces the amount of production that we have. So, there's a lot of considerations there. For builders, think about landscaping. You don't do things that are going to shade the system eventually. For other penetrations and, chimneys and plumbing stacks and things like that, mechanical penetrations, you're going to have to think about where these are going to go so you can optimize your solar system. So this homeowner, they wanted to maximize their system. Boy, howdy, they practically covered the entire roof with solar PV. Well, you can see that they strategically did their plumbing stacks in a way that basically that would be within that sort of allowable sort of rake edge limit to allow for basically the maximum coverage of solar PV. So these are things to think about as a builder. So let's do a mock-up example in Michigan. So, here's a system. Our home in Michigan consumes about 665 kilowatts per month. An optimal size would be probably about, shy of 20 panels, or about a 6 kW system. If we put that through PV Watts, we see that we're getting 7,724 kilowatt hours on an annual basis. And so basically, if we took a system like that, we'd be able to, a 6 kW system would be able to cover almost everything. The annual value of this production at about 19 cents per kilowatt hour, which is our going rate here in Michigan, would be about $1,500. So, that 6 kW system, if we go back a couple of slides to how much the cost is of something like that, and this was a guesstimate, 18,000, maybe 13,000 after the tax credit. So we'll have to see where it all ends up. But, if you're doing the tax credit, that's something that $1,500 per year that you're getting back in your pocket with this system. It's still going to take you a solid 10 years in order to pay for that system. So again, it's not always a slam dunk, economically, but it's something consumer may consider to do. Other thing that makes total sense to do is a solar ready system. So basically that's just setting up the home to be able to accept solar at some point. Planning, making it easier for installation in the future and less costly. And it helps to ensure that we're not making extra holes in the roof if a consumer decides to go and add a PV. So, we're going to put on the architectural drawings, where would the panels go? What would the conduit size be? And how is this going to connect into our electrical panel? Where are we going to mount the inverter? Ideally, it should be probably somewhere around where the electric service panel is. And we ideally don't want to put it right in the middle of the sun if we're putting it outdoors. We would prefer to have it indoors near the electric panel. Again, these are things we would do on the plans ahead of time. Running conduit up to from the electric panel up to the roof. is part of what we're trying to accomplish. Basically, again, to make it easy that someone might be able to put solar on without having to modify the home at some point in the future. That's what solar readiness is. So even if you're building a home today and you're not ready to add solar electric onto the home, that's fine. Don't worry about it. Go ahead and get it at least set up to be solar ready for some time in the future, so that a homeowner can make that decision themselves without incurring a lot of extra expense. Incentives, DT and consumers, there are again incentives through the utility for HERS ratings, but you can't use solar PV in order to get to the HERS index scores necessary to participate in the program. You can use passive solar or solar thermal though. And for if you're pursuing the consumer's bonus incentive for zero energy ready homes does require a home be set up to be solar ready. Now, how exactly you go about integrating it with the utility, it's somewhat complicated in Michigan, probably beyond the scope of this presentation, but essentially there's a distributed generation program that has an ability to credit homeowners, but we don't have what exactly is called net metering. Possibly a homeowner might be able to participate in some type of renewable energy credit program to get, or a carbon offset program to get additional value out of their system, something further to look into. So getting into HERS ratings and above code programs, so like in energy code, you don't get any credit for solar PV panels, other than if you're following the ERI compliance. There is a modest amount of benefit for passive solar when you're getting into the simulated performance, though. So, the impact on the HERS index, again, it's not required to have solar to do a HERS index rating, but solar, all three of them, passive solar, solar thermal, and photovoltaic, all can benefit the HERS score by lowering it. The things that you would collect for the software programs vary, but essentially you need to have, the peak power, total capacity of the system, the orientation, the tilt, and the inverter efficiency. In above code programs, Energy Star, you don't get any credit for solar installation. It's not required. It's not required to have solar, and it's not required to be solar ready. Zero energy ready homes does require you to be solar ready. You don't have to install solar though. Energy Star specifically, you can't use PV in order to meet your ERI target, but you could use passive solar or solar thermal. There's also, if you're going for a true passive solar design, there are some exemptions for some of the window requirements of the program if you're implementing a passive solar design. Zero energy ready homes, same deal as Energy Star. There are specific requirements for solar thermal water heating systems if you're choosing to implement that type of system. And again, you have to set up the home to be PV ready for zero energy ready homes. So basically, you have to make sure that on the plans, there's a location for the system that's identified, and that the roof was designed to accommodate that system. You have to show where conduit is going to go through the roof to be set up so that basically someone can just go and hook up the power directly for those panels if the consumer chooses to implement them. And you have to reserve a space in the electric panel for the future installation of a circuit breaker for the PV system. Passive house, FIAS gives a lot of credit for passive solar measures. That's a big part of passive house, is setting up the home to take in as much free heat from the sun as possible in order to offset our space heating usage through mechanical means. So that's a huge part of the FIAS program. There is some ability to be able to account for renewable energy in the source energy requirements for FIAS, and we'll get more into that when we cover the passive house programs later in this series. Renewable energy is also limited to on-site generation, though, when you're doing FIAS core. When you get into FIAS zero, that's their net zero program. Basically, the first action is conservation through passive measures and then adding PV. And that allows for both on-site power as well as off-site renewable energy. PHI, the other Passive House Institute, the European Passive House, again, passive solar is a big element of meeting that program because it has very rigorous space heating requirements. And there is now some allowance for renewable energy systems to be factored into PHI certification program. So both passive systems, passive solar, solar thermal, and PV to some degree could all be used both for FIAS as well as PHI. So I know it was a sprint to the finish there, but we were able to get it just 1 minute over. Happy to go into any more of these specifics in detail at another point, but check us out. We're going to be taking a week off here, but we will be coming back in 2 weeks to talk about optimizing building performance using the HERS index. We'll look forward to seeing you then. Have a good couple of weeks.